Hi, everyone, and thank you so much for coming and good afternoon. My name is Kyle. I'm the head of research here at Everest. We also have Dimitri on the call. He's our VP also of sales and marketing.
And Steve Scher here, VP of product development. Thank you for coming today.
We'll start with just a short presentation about our company and our product, and we'll move to the instrument demonstration. Here at Everest, our goal is to help you and help scientists to reach excellence in EV research by addressing the main challenges in using EVs for different research, specifically for clinical studies. So first, how to isolate exosomes in an automated, high-throughput way, and then how to do it in a reproducible manner. And also how to analyze the EVs we are isolating so we can see, for example, in our case, in site exclusion, where do they come out, in what fractions, and how can we get the purest EVs. And so our instrument is based on separating EVs by size. It's an SEC, which is widely used and adapted for isolating EVs from biofluids as well as cell culture. And it's also recognized by the MySIF guidelines. I'll just go over it very briefly. So basically, we're using these columns. Those are columns filled with resin. These resin are small beads which have pores, so they can trap, for example, proteins which are smaller than the pores. And so we add the sample, for example, plasma, on top of the resin, as you can see here in yellow. And then the larger things, like the EVs, will just go down by gravity and will elute first. So in the first fraction, we will have larger particles like the EVs, and the smaller particles like the proteins will get trapped in the resin, and then they will elute in the later fractions. And so we can separate the larger particles from the smaller particles by just collecting the early fractions in the SEC. And so this is our Ascent instrument, which we will go in lots of details in the demo later. It's an automated high-throughput EV isolation system. It can isolate EVs by SEC from 1 to 8 columns. It is compatible with our Apex columns as well as other providers like Izon. The main advantages here is that you can have a higher throughput isolation from other instruments. So you can measure more samples per day, which is crucial, for example, for clinical studies when you have a lot of samples to analyze. It is automated, so you have minimal hands-on time. So the instrument will isolate the EVs for you, and you can do other things in parallel. And it's very reproducible. So the EVs are being isolated in the same manner across the 8 samples, automatically giving you more accurate results. And so we've optimized our SEC columns. We are very transparent with the resin we're using in these columns. And we're collaborating with Sativa for getting the resin as well as automatically packing these columns. And so we have 2 flavors, one using the 6B Sephiroth resin. These columns are made for high yield isolation. And we have the Sephiroth 4B resin, which gives you a little bit less EVs, but they're going to be more pure. So they separate the EVs from the free proteins better because the pore sizes in the resin is a little bit larger. And we specifically optimize these columns to be very reproducible. So they drip in a very similar speed. So you will get the same fraction elution profile using the plasma samples or any other samples. So you won't have to have this variability between different columns. They can be used multiple times, up to 5 times we've tested them. And they allow you to use sample input of between 0.5 to 1 ml. Here you can see on the right, just the elution profile of these columns. In yellow, you have the 6B column, which as you can see, it's orange. It's a little bit higher. The EV are a little bit higher, so you have a little bit more EV, but you have in the dashed line some contamination of albumin in the later fraction because the pore sizes are a little bit smaller. And this data was created using our ELISAs. And so we think a very fast and accurate way to see in the SEC fractions where the EVs are, and basically to optimize what fractions you want for your application is to use ELISAs. So we developed these one-step ELISAs where you basically take your sample and you add our reagent, and you have one incubation step. It's very fast. and minimal hands-on time because it's only a one wash step. And so there it allows you to quantify your EVs as well as other contamination, for example, secreted albumin. And you can run individual columns of this ELISA, so up to 8 samples or the entire plate. And so we have an ELISA assay for intact EVs, where we capture and detect tetrastenins. And you can see here the performance of the assay using an absorbance reader. And you can use this assay to quantify the EVs in your SEC fraction, but also they were validated in biofluids. So just in plasma, serum, urine cell culture, and CSF. So you can really quantify also the recovery, how much of the EVs in your biofluid were recovered after the SEC, and really fine-tune what fractions you want to use for your application. To read these ELISA, we also have a very compact reader. It's an absorbance reader, which can measure the entire plate at once. You get results in a few seconds, and it's a very compact space-saving format, which I will show you in the demo. And so in the demo, we will go over our instrument, the two main functions it can be used for, which is washing the columns or doing the SEC fractionation. And we'll do it today with our Apex columns, and we'll show you how you can analyze these fractions using our EV ELISA. And so if you have questions, please feel free to post them in the chat or in the Q&A, and we can answer the questions while we demo or when we finish. So just feel free to post your questions. Okay, I hope you all see now the instrument. Yes, great. Let's take it as a yes. So this is how the Ascent instrument looks like. Let's just go over different components slowly. So here we have the user interface, which you can also see on the screen. We have 4 options: the wash, the run, and then service and configuration. And then inside we have a folder for the column, for the SEC columns. It had 2 different positions. So as I said, this instrument fits our Apex column as well as other columns, for example, a larger ISON column or smaller ones for which we have specific adapters. And so the top part is to have more distance from the stage for the larger columns, and our columns go in the bottom position. Then we have here drop detectors. So they're going to monitor the dripping of these columns to know when to add more buffer or when the instrument needs to wait. On the bottom, we have the liquid waste, and we have the stage. And on the stage, we will put our tubes. And so we have this tube holder. It fits 2 ml and 1.5 ml tubes, and it has 2 different positions. So for the larger column, it will have a shorter holder. So again, to have enough distance between the column and the tubes. And for our columns and smaller columns, it will be elevated with this stage. Let's just go over the wash option. We will not demo it. We'll just go over it. We will demo the entire fractionation step with a wash. And so here in the wash, basically the parameters we can change are what column we're using. So again, the different columns should be on the top or the bottom holder. So today we're going to run the Apex column, number of columns. So you can wash between 1 to 8 columns. Then you define the wash volume. It can be up to 40 ml. Then you have 2 additional options. One option is to do a column saver. It's a very nice option where you don't want the column to get dry after the instrument finished the washing. And so it will continue add more and more buffer until the user comes and gets the columns out. So you don't have to rush to the instrument after it finishes washing. You will have time to take the columns when you're ready. And the other option is the water rinse, where it will just, after it finishes washing with a PBS or a different buffer, it will just flow water in the tube to prevent salt crystals on our tubing. That was the wash. Let's go to the run. So the run is for basically washing as well as collecting the fractions from the columns. Let's go over all the options. Again, we should choose what column we're using. We have now all the different options. Today we're using the apex column. Then you can choose what flavor or what resin type we're going to use. It's going to run the same for the different resins. The only difference is that it will upload the default values which the supplier recommends for this column. So, for example, a 2B resin sometimes recommends different fraction collection than a 4B. So you'll have these default values uploaded automatically. Then you can choose the number of columns you want to use, again, between 1 to 8. Today we'll do 8 columns and some apex. Then you can define the wash volume. So before collecting the fraction, you can have a wash. And for today, we'll take the minimum wash, so it will be faster. So we'll do 1 ml of a wash. And then the discard volume. So basically, after you will add your sample, you will want the instruments to add more buffer, which will not be collected. That's the void volume or the discard volume. So basically enough buffer to get your EVs to the bottom so you can start collecting them. So again, for today, so it will be faster, we will just make it 0.5 ml. Then you want to define how many fractions you want to collect. This instrument can collect between 1 to 12 fractions. For today, we will have 4 fractions. And you're defining the fraction volume. So what is the volume of each fraction the instrument will collect? So after I go over all of the settings, I can press next. Then it will ask me what other options I want. So there are 3 options. The first option is a post-column wash. So if you want, after the instrument is finished collecting the fractions, to have an automatic post-run wash of your column, you can just define here that you want the columns to be washed and what is the wash volume. We will not have it for today. The instrument water rinse, like I said before, just washing the tubing with water. And then again, the column saver. And so the column saver in the run will work in 2 different places. First, after the instrument finished doing the pre-run wash, it will continue to add buffer. So again, you won't have to run to the instrument when it finished washing the columns to add your sample. It will alarm you that it is ready for you, but it will continue add more and more buffer. And also at the end, after it finished collecting the fraction, it will also add some buffer so the columns are never dry. So we will have the water rinse and the column saver on for today. We'll press next. That will ask me to confirm the bottles. So we have here 3 bottles, 1 bottle for buffer. Usually we use PBS, but you can put here any buffer you typically use. And we have the water, which is, if you're doing the water rinse, you should have some water in your bottle. And we have a waste container, which should be empty for the experiment. And so you just have to confirm that you have enough buffer, enough water, and enough place in the waste bottle. And then you will have less than 1 minute of initialization. During this step, the instrument initializes the stage, position, the pump.
It primes the pumps, make sure there's no bubbles in the line, gets everything ready to start the experiment.
Okay, and it shows you how it progresses. So now it's in the middle, in the halfway to the initialization.
Getting the waste as well.
And it moves the stage to the front, so I can place there the tubes. Okay, so now it shows me where I should put my tubes. I chose to collect fractions from 8 columns, 4 fractions. So I should have 4 times 8. And it will tell you exactly where you should put them. So again, we have the numbers here and the letters here, so we know where to put the tubes. Now, if you had colors already in the instrument and you're scared that, and they are uncapped, and you don't want to prevent drops from falling on the tube, we have this drop catcher. So you can just put it in before you add the tubes. So when the stage moves back, no drops will drip inside your tubes. But currently our columns are closed, so we are good. So I'm just going to put the tubes inside. And again, for the smaller column, we have the higher stage to have a good distance between the column and the tube. So I'm going to press next. And the instrument will move the stage to the back. And now I have access for 8 columns. And it tells me, again, I chose 8 columns, so I should have 8 columns in the holder. And it shows me when I need to put the column holder. So if I put it in the wrong place, it will give me an X. And if I put it in the right place, it will give me a check mark saying I'm good to go. And then I need to open on the columns and also uncap the bottom. So I'll do it quickly. Yeah, and you have to confirm that you uncapped all the columns before you proceed.
These are fast dripping columns that we use for this demo just to speed up the process. So normally they don't drip quite that quickly.
Don't hesitate to ask questions in the chat box while this is going. I'm sure you have plenty.
Okay, so now my columns are ready. I can check that they're all uncapped. If I would have the drop catcher in, the instrument will tell me to take it out. Nothing will block my column. And after I close the door, I can press start. So now it lets the column drain. So usually they have some buffer on top, so the instrument will wait for the buffer to go down from all the columns.
So we use the optical drop detector to make sure that all the drops have stopped and wait a sufficient amount of time after that to proceed to the next step.
And you can see on the screen how it basically tells you in what step we are. And so now we are in the column wash step. So it's adding buffer just to wash the columns. We defined here 1 ml of wash. And as it will progress with the washes, it will tell you how much volume was already added to the column. So you can see where you are in the washing step. And this is a very short wash, but sometimes I do 20 ml of wash, so it can take longer. So here it finished a 0.5 ml throughout the column. Now it's adding another 0.5 ml. And it will again wait for the buffer to flow through. And when it finishes in all the columns, it will move to the next step.
You want to answer this question?
Yes, I have a question in the chat regarding the reproducibility. So it was based on our EV ELISA using the sum of the EVs in the EV fractions, comparing the different columns. Okay, so now again, it's waiting for the columns to finish, to drop, and it's done. And now I need to add my samples. I'm going to press continue. If I was not here, it would start the column saver. It would continue to add more buffer, so the columns are not dry. So now I will add the sample. This is the only manual step in this process.
We see your cluster. We'll get to that in 1 second.
Okay, so I'm basically adding my sample to all the columns. And of course, you will add different sample or whatever you want. This is just whatever for this demo.
Great. We have a couple good questions here.
Okay, press next. Gonna wait for them to stop dripping before moving to the discard volume.
It's actually a perfect time to get to the questions then. We'll start collecting the fractions in a second.
Okay.
So the first question, have you compared reproducibility via NTA or RPS?
We have not yet. How was the column being okay for reuse up to 5 times determined? Was it also based on the EVIs? So for this, we quantified both the EVs, but also we quantified albumin as a free protein. And so we will have this data in our website. So we both looked at EVs and the purity compared to albumin. Again, sample is not fixed. It could be between 500 and the fraction volume will change. Do we need to adjust? Yes. So if you have different sample volumes for different columns, you would like the sample to go through, add your correction buffer like you do manually, and then from there it will be automatic. So now basically add discard volume, and it's waiting for the drops to finish, which they did. So it moved the stage to the first tubes, And now it's basically collecting the fraction. So each column is above a tube, and it will just add the buffer and again, wait for the PBS to finish dripping before moving to the next fraction.
So this next question, are there any safety net mechanisms in place should something go wrong with the machine? Is the sample safeguarded against instrument malfunction? We do have kind of logic controls in the software to make sure that doesn't happen. And if you do see some sort of significant failure, you can abort the process at any time, and then you can open it up and take your columns or samples out.
But in the initializing step, we are testing the
Yes.
stage to make sure it moves to the correct location.
Mhm.
And so we will have this feedback before you start the experience. So it happens, the initialization for every round, not just in the beginning of the day. So it will do this test again. Okay, so now we're actually in the last fraction, because those are fast dripping columns. After it finishes, you can take your fractions out. It will tell you it finishes. Or if you're not here, because we had the column saver on, it will just continue to add buffer to the columns. So they're not dry unless you had the post column wash option on. It's doing the water rinse. It's just pulling water, so the tubes will have water and not buffer. We haven't encountered any problem with having buffer in the system, but salt buildup because it's PBS or other buffer. And so it is recommended to wash with water at the end of the experiment, and it takes only a few seconds.
So as another question, have we compared the output of our instrument with the ISON AFC?
It is known the accuracy of the AFC. The AFC is very different because it collects a lot of fractions from one column, whereas we aim for collecting multiple fractions, but from multiple columns. And so you have in our website our accuracy in dispensing and the accuracy of the fractions. We have all this information, and I'm sure ISON have this information for their instrument as well.
One question here, what is the highest volume? So the highest sample input volume for our columns, the apex columns, is up to 1 ml, but it is a settable parameter, so you can adjust that.
So if you have
Yes.
larger volume, you should adjust
And you can do
the
smaller.
void volume. And we have adapters for the smaller columns, so the instrument works with them as well, and the larger columns, as I showed you in the demo.
So the fraction volume can go from 0.1 ml up to 2 ml.
And so basically now we have the fractions and they're ready.
We don't have columns specifically for a smaller input volume, but the instrument is compatible with an adapter that we have with the ISON QV singles.
So usually we test these fractions with our EV ELISA. It's because it's much faster and it's specific for the EVs and not just any particles like NTA. And so in the plate, you can run the entire plate, or you can just take out strips. So you can run just 8 or more samples at a time. And we have this compact tweeter, which can connect to any computer by USB, so a laptop. It's absorbance-based reading, and the user interface is very straightforward. Basically, you just tell it where your samples are. It can do the quantification for you, so you can have a calibration curve, and you can have the samples next to it, and the blanks. Then you'll just go to readout, and it will just do initialization. It's very fast, a few seconds. You insert the plate, and you just press read. And the reading is like 2-3 seconds, and you'll have the results. And so in the results, here at the top in yellow, you have the ODs of all your sample. Then if you had a calibration curve, it will fix the calibration curve for you, and it will interpolate all your samples using this calibration curve.
One question here. So yeah, that's correct. We use a high precision pump to dispense an accurate amount of liquid into the columns. And then we have the optical drop detector to make sure all of that fluid has flowed through the column. And that's how we know how much we're dispensing in each fraction.
And so this instrument doesn't need to be calibrated like the AFC. It's based on the dispensing and not based on weight.
It makes it fairly robust to vibrations and other lab equipment as well.
Yeah, we just move it around all the time.
Yes, we do quality control before it's installed in the instrument, and we do have a lifetime for the pumps that we can share.
Feel free to shoot us an email, Steve, myself, Dimitri. Happy to answer other questions later. And I think I didn't say, so this instrument works with our column, but these columns are just regular SEC columns, so like they can work also on your own column stands. So just like any other provider of columns.
We specifically made these columns, as Tal said, because we really had a mind towards reproducibility, which is something that I think is very important, especially for the larger trials.
Yeah.
So that was kind of one of our primary requirements when making these columns, is to make sure they were very reproducible.
Yeah. I think the motivation for all these tools came from, I was doing EV research in my postdoc, and I realized how if I want to measure 200 samples, first of all, doing manually and watching the drops is not so accurate and it's very time consuming. And second, if the columns drip in different speeds, the evolution will be different. And so I'll have to collect different fractions. And so for measuring a lot of samples and actually comparing the results between different samples, for me, it was very important to think about automation and reproducibility of both the instruments and their consumables.
So there's a question here about which validated markers do we offer for the ELISA kits?
So currently we have a one intact EV validated assay. All the validation is also on our website, where we capture receptor spannings and detect receptor spannings. In the future, we aim to have also homebrew assays where we can do more interesting assays, but currently it's just tetraspannings detect and capture, and as well as our contamination kits if you want to measure both the EVs and the contaminants to really fine-tune the fractions you're collecting. So it's HSA. Humans, do you ask because of cell culture? I'm going to assume yes. Okay. So for cell culture, I usually just do nanodrop because the DSA is so high. This is specifically for human samples where I take human serum albumin as the most abundant secreted protein, which I don't think is on the EVs. So it's a good marker for me to look. We also have assays for lipoproteins, which apparently are not commercializing, but happy to talk about it if you want to shoot us an email. Oh, product warranty. Yes.
Dimitri, you want to respond to that one? Is there a product warranty?
There's a product warranty, so it's 1 year parts and labor, and we can provide an extension if that's required. You're welcome.
Okay, so have a great evening, everyone.
It was great to have everyone attend.
Yeah, thank you for coming.
Thanks for participating. Good day.